trying to do, or so that everyone understands. So it's one-way ANOVA. Let's not explain ANCOVA, MANOVA. Let's ignore that for now. But for those who are doing it high level, I will try to do other videos that can help us. Yeah, but for now, let's focus on people who want to graduate and those who don't want to fail their undergrad program or maybe at honors level. So it's analysis of variance. So like what I say, t-test is also kind of variance. You compare the variance that we can explain and then the variance that we cannot explain. So ANOVA is used when we have 2 or more treatment or groups. So it's for same as t-test, test for difference. So there's one independent variable. So it's called a factor. So you see there's only t statistic, but ANOVA it's a F ratio. So it's kind of a ratio. It compares what happens in the numerator and the denominator and compares the two so that we come up with F ratio, okay? So we follow the same stuff. So now we have another condition. That's why you're using ANOVA. We can read around the family-wise error. So why are we not using a number of t-tests, but we're combining it like that? Yeah, we can read around that. Let's not dwell on that. So now we had in that group same values. We had alone and then a comeback. Now let's see if the child's going to be anxious. If you don't know the story, watch the rest of the videos. It's a true story that happened, but now we created fiction value so that maybe no one will sue us that we are using their study. Okay, but maybe one day we must do the study. So we have now three conditions like this. So that's what's happening. So we want to compare if there is a significant difference, or if at least there is a difference between between 2 of these 3 groups. So that's what we want to do. So the same steps, you state the hypothesis, so it's different. So I don't want to move like this. Sorry guys. Let's stop it here. So you state the hypothesis. So there's no significant difference. The difference is 0 across the groups. So this is the population mean. There's no difference. And then in the alternative hypothesis, at least one of the groups is different from another. So this one can be a no equal sign here, or maybe even on both of them. So that's what we do the same. I think we are cool with that. Everyone, we've watched the videos. And then now the difference is that for an ANOVA, you still locate the critical value in the critical region. What did I write here? Locate critical value in the region. So the degrees of freedom here is quite different. So use the degrees of freedom of total. So we say number of participants. So we have 11 in each group. Remember in each condition. So it's n minus 1. So you have 33 minus 1, that's 32. And then degrees of freedom between, so number of the treatments minus 1. So that's 2. And then the degrees of freedom within. So it's sum of the degrees of freedom. So that's 30 of, it's n minus 3. So that's 30. It's a number of participants minus number of groups. So there's an implication if you add more groups for a condition, it can affect the outcome of the F ratio. So the third step of what to do, look, before I forget, so some of the lecturers, they want you to test for assumptions. Like what I said, I'm skipping that so that we don't waste much time, but I will do a video for assumptions and what are they, and then how can we test for that. And how important, I think it's very vital, we understand that. But for now, we want to understand how do we do the manual calculations. So the first thing we want to do, we want to calculate the F ratio. So you obtain the sum of squares between and then sum of squares within. So you use the sum of squares values and degrees of freedom values to get, like they explain in this table. So that's the explanation of what's happening here. Let me just push it a little bit up. So before I forget, so if you go to the back of the textbook, if you go to find the F crit, so there's a denominator and so you are using these values for between group and then the within group. So you check at 2 and 30. So where they meet, you're going to see there's a 3.32 under 0. Not 0.05, but technically we say 0.05. So if it's 0.01, you must be careful. You must check under 0.01. So you must be careful about that. So I wrote that for you. So you can check as we move forward if you do the practices. So so under that step to calculate F ratio, so we need to calculate the sum of squares for total, the grand total. So for that to be easy for you, you must arrange your scores like what I did here. So these are the scores, these are the scores, are scored, and then you add, I don't know what's happening here, and then you add the total. See, this is the total, that's 72, this is the total, that's 69, this is the total, that's 57. And then the mean for that is 6.55, the mean is 6.527, and then this is the mean. And then you remember, in our other video, we calculated that the sum of squares for this alone, for children watching the movie alone, was 30.73. And then for second group was 40.18. Watch another video for t-test, you'll see that. And then if you do the calculation again, you see that I did that for you here. So we square the values, and then we square each value, and then the sum of that. So sum of squared x's. So that's what it means here. And then minus, in brackets, sum of x. So we square that. Sum of x, and then you square. It means that 57. And then you square that number and divide by number of scores that are in that. So it's 5, 10 minus whatever. So you get, this for group 1, this for group 2, and then this for group 3. So it's 49.64. So these are the values. I'm just showing you where these values came from. And then we use those values. So and then the grand total, the number. So we want to come back to this one. The total number of participants is 33, yeah. And then the total, the grand total, if you add 72 plus 69 plus 57, you get 198 here. And then if you add all the squared numbers, like what if you add 5 squared, 6 squared, 7 squared, 8 squared, 4 squared, 4 squared, 3 squared, and all those numbers, you're going to get 1,326. All the numbers in that experiment, if the scores, we square them. So this is this number. So if you so 198 squared is 39. I tried to show you how can you follow that here. So if you do that, you're going to get 140. Okay. So this is the total. This 140. So there's this table. If you check in a textbook, how do they arrange this table? They write like this. So I just fill in the gaps. So it's 140. And then for within, so it's sum of squares in each treatment. So it's 38 plus 40 plus 49. These three, 48 plus 40 plus 49, of which is 128.55. It's this one. And then the between one is easy to get because we can just subtract these two. So you get the between. So like what I showed you here, that's 11.45. And then we did the degrees of freedom already there before earlier. So this is 2 for between, and this is 30 for within, and then 32 for total. And how do you get this 5.73 now? So it's 11.45 divided by 2. So that's how you get the MS. And then the MS also within, you say 128.55 divided by 30. So you get 4.28. And then if you divide these two numbers, you get an F value of 1.34. So, and then how do you make a decision? So that's ANOVA. So how do you make a decision? So this is very, very important. So we want to compare this 1.34, and I want to see if it falls in the critical region or not, and compare it with 3.32. So, and then you make a decision. I did this for you at the bottom. So I don't know this. Okay, sorry guys. So if it falls, like what I showed in the t-test, if it's more than if the value that you obtain, if this value is more than the critical value, you reject the null hypothesis, like what I'm showing on that diagram that I showed. Sorry for my writing again. So 1.34 is less than 3.32. So we fail to reject the null hypothesis. So this is how we conclude. That's step number 4. You make a decision. So I wrote for you very nicely here. So if value obtained is less than critical value of 8.05, therefore we fail to reject and conclude that there is no significant difference among the 3 conditions. But if there's a significant difference, you can continue or proceed to calculate the effect size or a post hoc test, but we don't want to focus on that. I think it's making sense. Yeah, I think, yeah. Thank you so much. You can watch more videos. There's another one similar to this, but we did with Excel. You must watch that. It's very important. Yeah, I wish you the best. Watch out for more videos. We can share. If you want me to send you these videos, you can send me an email. I'll do that. I can send you an email. I don't have a problem with that. Thank you so much.